Okay, hello everyone. So what I want to do in this video is to show how to mesh the frame component of the simplified CubeSat assembly that you see here. So to do the frame mesh, we start with the assembly. We're going to need that eventually in order to split some of the faces of the of the frame. But to start off, let's make the frame the work part, and in fact, let's take a look at it in the open in a separate window. Okay, so we have it in the assembly navigator. Let's take a look at the part in the part navigator. And you can see that it's got a number of features to it. Let's take a look at, if we do a feature replay, and we go all the way back to the beginning. If we do a feature replay, the first feature is the rails. And then we set up this datum plane, which is a rather key feature of this part. And then the rail supports are done, and then those rail supports are then patterned to complete the frame. So taking a look at this, I think the best spot the best thing to use here is this datum plane here. If we take a look at the frame, so let's edit the sketch here of the frame. Let's do this renew and edit. Okay, so you can see here we've got the 4 rails being created. Each one is an 8x8 square. And then the outside dimension is 100 millimeters, and the same on the other side. Now so note that the center of this these 2 rails, I suppose, is 50 minus half of this distance, so that's 46 millimeters away from the center line here, or the center plane. Okay, so let's go back. Okay, and if we look at this data plane here, we double click it, it's actually 46 millimeters from the center plane as well. So this is the center plane of those rails. So we're going to take advantage of that in order to create our lines and geometry for the beams that we're going to need for this rail. So let's create actually a sketch, and we're going to create the sketch on this plane that's already existing in the part. We're going to click OK. Okay, and let's move this here. So what we're going to do, we're going to create some lines. So we click on the line. And when we do that, we're going to take advantage of some of the point location tools. Here we're going to make sure that the midpoint is highlighted. And if we zoom in here, we're going to use the midpoint of that line. And we're going to connect it to the midpoint of this line. Let's zoom in here. We're going to create another line from the midpoint of that edge all the way up to the midpoint of this edge. Okay, so notice that I selected the midpoint of this edge here, and it automatically projected it onto the plane of our sketch. Okay, likewise, let's use this and the midpoint of that. and then do the same thing for each of these support rails or rail supports. Like so. Okay, so then what we want to do is we're going to use some of these trim and extend tools here. Let's first of all extend. So the boundary curve we're going to use is this rail here. And then we're going to select this curve to be extended. We're going to make another curve extension, same with over here and over here. Then we're going to use the other side as the boundary, and we're just going to go down and extend the curves on in the other direction. Perfect. Okay, so now we've got this, all of the center lines. Now, notice that I've chosen the center line of the rail, but I've not chosen the center line of these rail supports. Okay, so this is I guess, an idealization that I'm making, that I'm not putting the thermal conductor through the center line of this rail, of this component, but that's sort of, I'm just going to make it that sort of simplification here in the model. Okay, the other thing that I have to do is, it seems counterintuitive, but I don't want to mesh this complete rail, as I want to make sure that I have a break here or a node here so that I get a thermal conductance connection between the rail and each of these support rails. So what I'm going to do is actually trim these. It seems strange to do this, I know. Same with the other side. And then I just create a line from these endpoints. Again, make sure that the snap options, make sure the endpoint tool is selected. So then we just reconnect them here. Oh, sorry, I have to do these one at a time. And then here to there. And then here to here. And yeah, you notice that it fills these in automatically because we've constructed an enclosed area, so I can actually extrude this now into a solid, but I don't want to do that here. Okay, so that looks good, and that's ready for meshing. Now, the other thing we talked about in the tutorial was we're going to mesh. So if I go back to here, sorry, I want to go back to the assembly. So recall, so if I go right back to the assembly here, these parts, or these faces of the rails, are actually external, and the other components or other parts of the rails are internal. So we need to make a 2D mesh around these faces. Okay, so we're going to split these side faces here, and also this end as well, in order to create 2D meshes. So let's go back to our frame here, and we're going to use this divide face tool. Okay, we're going to select the face. So let's choose actually this rail, and we're going to choose this face, and then choose the offset curve, The offset curve will be this end line here, and we actually want to reverse. It's going to try and divide the face off the face. That's why we're getting this alert here. So we'll turn that around, and actually what we want to do is make that a little bit further down, and I think it's an even 5 millimeters. Gets us right to the edge that we need here. Okay, so let's apply that, and then choose another face. So we're going to choose this face, select the end edge of that, and then it automatically picks up 5. We're going to do that. Choose this face, end curve, 5 millimeters, and we're going to choose this face, the end edge, 5 millimeters. Let's do that to the other end of the rail. Okay, so we'll select the face. There we go. Reverse direction. Apply. Let's use this face. Apply. This face. Reverse. And this face. Also reversed. Okay. So now what we want to do is to split these other faces. So let's choose. So we want this top edge of the printed circuit board. So if we do that, let's actually, before we do that, let's go back to the assembly. Okay, so you can see here it's current with what we're doing, and let's, when we do this split, so our simplified frame is still, make sure it's the working part. We're going to come in here, we're going to again divide the face, or we could come over here in the frequently used commands or recently used commands and select divide face from here. Now we're going to choose that face, and we're going to use this offset curve option again, except this time we're going to use this face, and here the handle is actually too far down. And it turns out that at about 2.5 millimeters, we're actually matched up with the top face of the printed circuit board. Okay, so we'll use that one. So that splits that one. And then we're going to come over to this face and split that in the same way. And we're going to reverse that. And again, it chooses, remembers that 2.5 millimeters, and that's also correct. Okay, so let's go back to our simplified frame, and again, either view of this part, and we've got the most current status here. Okay, so let's save that. Now what we want to do is start our meshing. So we're going to click on Application, Pre and Post. We're going to create a new FEM and simulation. Okay, so that brings up this window. Now, some important options to choose here. First of all, definitely an idealized part. We're going to use that. Geometry options. We're going to turn them all on, including the sketch curves, which is really important because the geometry we're going to use for the beams is in that sketch curve. Okay, so we click OK there. We're going to make sure that the solver is the SimCenter 3D Space Systems Thermal, so make sure that's the solver, and the analysis type is thermal. Okay, so then we click OK to that. Okay, and we'll create a solution, that's fine. And then click OK. Okay, so you see here we've got the assembly, we've created our simplified part. We've got the separate simplified part. Now we have an FEM and a sim file to do our to capture or continue on our modeling. Okay, so here it's put us into the FEM, and if you expand this polygon geometry here, what it's gone and done, so let's turn them all off, and what it's gone and done is it's split up all of the different extrusions and components of the model into different polygon geometries. So what we're going to do here, we're going to turn off, no, we need that one. So you'll notice here, this is the one that we've split. So we're going to use this geometry for the surfaces, and then we're going to use this geometry, the split geometry, for the rails. Okay, so let's first of all rename this one so we can remember where it is. So we're going to call that rail geometry, let's say. Okay, but let's blank that one out, because let's start with the rail and support rail geometry. Okay, so probably the fastest way to jump into this, I know before I've sort of shown you to create mesh collectors and so forth. If you just jump into 1D mesh, and let's select, so there are two I guess components here. Before I do that, let me turn on at least one of the rails. Let's turn on one rail here, support rail, sorry. And let's also turn on a different major component. Okay, I'll show you why I need that in a second here. Okay, so let's go back, 1D mesh. Okay, so the easiest thing to do here is to start with the 1D mesh. Now we haven't created any mesh collectors, that's fine. So what we'll do here is select the objects. So we select all of the rail line segments. And that's fine. We select or specify an element size. The beam is 300 millimeters, or the rails are each 300 millimeters long and 36 elements per beam. That's fine. We want to merge the nodes. Here we're going to create our collector sort of on the fly here. So first let's create our material. And then we specify appropriate values, which we'll look up and document, making sure that the units are correct as we enter them. Okay. So we click OK. And click OK one more time. So we're back in the mesh collector, material is selected. Let's now also create a rail physical property, 0, and OK. Now we'll create a cross section. So here what we're going to use is the type here is face of solid. This will be the name of the cross-section will be the rail cross-section. We'll choose a face, so here we'll choose this face of the rail to give us the cross section, and this vector, it needs to be perpendicular, so I could have chosen either one really. It's square, so it doesn't matter which way it's oriented, okay, but either the x-axis or the y-axis, since the rails run along the z-axis. Okay, so then we click OK. And so we've got the rail cross section, so we click close, and again the rail cross section is there. Now these beams are not, remember we're going to coat the beams, let's say, with the surfaces that are outside. So for the beams themselves, they don't have radiation. Okay, so then we create rail, or the name of our collector. So we click OK. And here we are. Let's take a look at the mesh. And that seems to be a nice mesh here. So let's click OK to that. Okay. If we minimize this, we've got our 1D collector here. We've got our rails. We can edit the display. There's a shrink option, which is always good to do, and then a solid. So if I apply that, you can see I like to put on the shrink because that shows you each of the different elements here. Okay, so that's looking good. Let's click OK to that. Now, the next thing to do for these is now to, we can reflect them. So that's done over here. We go to the Nodes and Elements tab. We come over here to the Elements group, select More, and then, whoops, and then come down here to the Edit group and select Reflect. So the mesh we're going to choose is this 1D mesh here. Okay, the plane. Now here is where it's a good idea to locate. So when I created this assembly for you, I located the WCS, or the coordinate system, along the center line of the whole spacecraft. So that's actually a key thing here. We're going to use this to quickly do our reflecting. So here we're going to choose the XZ plane. YXZ. I chose the wrong. XZ. Here we go. Okay, and no distance, right along the center line. We click OK. Let's see what that's going to look like. And that looks good. So let's click OK to that. Okay, let's go up here and turn off that rail geometry. And then while we're at it, let's turn off the rail mesh. Okay, so the next thing we're going to do, let's go back to the Home tab. Let's create another 1D mesh. And let's this time select those rail supports. Okay, and here we're going to create a new collector, which we're going to call rail supports. It's not going to have any radiation. The material here will be the same aluminum material as the rails were. Here we're going to create rail supports and the same 0 non-structural mass. And here we're going to use, again, the section. We're going to create a new section. Here we're going to call it rail supports. And then we're going to use the same face of solid, and this time though we're going to choose this face. And then we're going to choose a perpendicular. Let's choose the Z-axis here. And we'll click OK. Okay, so now we've got that section done. And so that gives us our mesh collector. And then let's have a look at those. I specified the same element size, or the same element size that I did before was memorized and or selected for me, so that looks good. Okay, so that's good. Let's select that. Now, we've created this second set of elements here, and I want to check that the node here at this intersection of these three beams is the same one. So the way I do that, first of all, let's turn off this last beam here. And let's also turn these rail elements back on, and let's turn on. So I've got the display of the rail. Let's also edit the display of our rail supports. Again, turning on shrink and a solid connection there. So now we've got the rail supports there. Now, I've created this mesh, and I want to make sure, well, first of all, let's go ahead and reflect this one. So we're going to come up here to the frequently used commands and click on reflect. We're going to choose the support rail elements. We're going to choose again the XZ plane, XZ, with no offset. Look at the result, and there it is. Okay. And let's go ahead and create finally also the other rail supports before I show you how to do this node merging. So we want to create a reflected set of elements here. But it needs to be about a 45-degree plane so that I reflect these ones over here and these bottom ones to the other side. So what I believe I need is a plane. So again, I'm going to do a reflection. I'm going to choose for the geometry or mesh, I'm going to choose the two elements, the two meshes of the support rails. I'm going to specify a plane. Let's choose at an angle. So I'm going to choose this sketch plane again, and I believe the linear object that I need, let's turn on that one. Okay, and let's choose this edge of the rail, and we need, I think it's 45. Let's try this one. Click OK, and let's look at the result, and that's the one we need. Okay, so we've now reflected the other sets of rails. Okay, let's turn that back off. All right, so now we've created all these different sets of beam elements, and what's going to happen is we've got duplicate or coincident nodes at the ends here. So we want to eliminate those. So what we do is we come up here to Checks and Information group on the Home tab. We click on the More here. And what we want to do is I believe it is duplicate nodes. Yes. Okay, let's try duplicate nodes. And the nodes to check, let's just click and drag a rectangle around everything that we see here. And we're going to list the nodes. So when I click on my list, I don't want to bring the list window into this window because it's going to screw up my recording. But I can see in the list that there are a bunch of nodes that are coincident here. The distance between them is actually 0. So let me X out of that window. It's off screen when you do it. So what I want to do then is merge the nodes. Okay, so when I do that, it retains the lowest node label. Let's actually run that again. So we're going to select all of the nodes. Okay, we're going to list the nodes, and again, off screen, I'm getting 0 coincident nodes. Okay, so that's fine. Okay, so then the last step here is to do this meshing, the 2D mesh. So while we're doing that, let's turn off the beam elements that we've created, and let's also turn off the line geometry. We can do that by going Control W, and let's turn off the datum plane, and let's also turn off curves. Okay, and then we'll click close. Alright, so we're going to do a 2D mesh. Let's carefully select the objects now. We're going to choose these 5 elements on the end. Okay. Then we're going to choose this one, this one, this one, and this one. Basically the external rail surfaces. Those are the ones we want to create elements on. Okay, we choose the quad 4 thin shell. We're using an element size of about 9. That gives us roughly the same length. It'll sort of look better in a second here. You can see the size is about right. We're going to minimize triangular elements, merge edges, as it has here, and then the destination collector, we're going to try and create our own. It's not letting us. Okay, well, let's fix that once we get it meshed. Okay, let's go ahead and show the result. Okay, and this looks pretty good. Now you'll notice here at this spot and this spot it creates a couple of tries. Same thing with the other end. I think that's it's okay. I mentioned that tries are not the best, but in this particular location there's really no other good way of getting around that. So I think it's okay to have 4 triangular elements in the whole model. Okay, so we'll click OK there. Now we have to fix that issue with the shell collector. So we're going to come in here. We're going to edit the collector. Okay, so here it's a thin shell. The material is going to be the same aluminum from the beams. The property here, let's edit the property. We're going to edit the name. Let's call this rail surfaces. And the thickness, we're just going to use like 50 microns or something like this. It's just the top surface of the beam elements here. Okay, so we'll click OK to that. And then radiation, we're going to have top only. And then we come in here, we're going to create our own. Oh, sorry, I don't want that. I want to open the manager. And again, remember, when we have different values for emissivity and absorptivity, we need the advanced properties. And then we call this one rail surfaces. We're going to create that. And then here, you would go to probably that database that I have on the website, and you can enter appropriate values. I'm just going to enter some random ones here, 0.9 and 0.85 or something like this. Basically, you would have you enter, look up the properties and appropriate properties. This is anodized aluminum on the outside of the rail. And typically it's a black anodized, so that would be what you would look up here. Then click OK. All right, so then we come down here, and we've got only the top surface, and we have our properties, and we call this rail surfaces. Okay, then we click OK. All right, so now that's fixed up. And so what it did was it created a mesh for each of the different surfaces that we meshed. Okay. So let's go back and just sort of, I guess we can just turn on the 4 rails. Actually, let's not. Let's leave the polygon geometry off. Let's turn on the beams so that we can see those. And actually, let's change the color of all of these. And view, object display. Let's change it from green to, say, a blue. Or maybe a dark. Yeah, let's do that since it's black anodized. And apply that. Okay, so that's what that looks like. Okay, so now what we want to do is we're going to reflect those. So let's go ahead and copy and reflect. We're going to select all of the rail surface meshes. We're going to specify the plane. We're going to do the XZ plane. So we choose the XZ plane. We click OK. And let's take a look at the results. Okay, that looks right. Looks like it's going to be okay. So let's click Apply. Actually, and let's change these, the color of these ones. Also to that gray. And apply. Okay, that's good. Actually, so let's turn off these rail elements. Okay, that looks good. And so let's do a final reflect. We're going to choose again all of the rail meshes, and this time our reflection plane will be the YZ plane. YZ. Click OK. Let's see what that's going to look like. and that looks right again. Okay, and then let's go ahead and make those the same color. Okay, perfect. Okay, and we can even turn on the rail beams. Perfect. Okay, so now what we need, let's first of all save. So there's our FEM. And now what we need to do is create a simulation. And the best way to do that, I think, I got messed up here. Let's go home. And if I collect, there should be a way to add a simulation. If I do this, new simulation. Oh wow! Even though it's grayed out, let's choose create a new simulation. Okay, so it's going to be the same one, the same name, the FEM1 and Sim1. Okay, and it's going to use that FEM that we have, which is this one. Perfect. And let's create say OK. And let's create a solution even. Okay. Now, the reason why I do this is because when we put together an assembly FEM, we're going to have to create one within this model, this mesh. We need to join all of the surfaces with the corresponding beam elements. Okay, so you can see the beam elements, not these are the rail supports, but the beam elements sort of inside. So we're going to create those together. So we're going to create here we are. Oh, let's get rid of this one. Sorry. Sorry, cancel. I just want to cancel this one. This simulation, no, close. Okay, let's do that again. Okay, so I'm in the FEM. I want a new simulation. And I forgot to change it to the correct Space Systems thermal template, but it's this. Everything else is the same. Okay, so that's the one mistake I made there, and yeah, otherwise it's correct. Right. And create a solution. And click OK. Okay, so now when I come over here, now there's two ways we can do it. We could create a coupling, or we can create a merge set. But I think I'm going to create a coupling. So let's do this. So object, thermal coupling, regular thermal coupling. And the type will be perfect contact. This will be called rail beams to surfaces. And the primary region will be our rail beams. So let's go up here into the FEM and into our 1D collectors and select all of the rail elements. Okay. And then for the secondary region, we're going to come down here and we're going to select all of the rail surface objects. And we're going to choose filter, make sure. So the primary region, we've selected the beam elements, so we have to make sure that the filter is set to 1D. For the secondary region, we've chosen the 2D, all of the rail surfaces. So again, our filter type here has to be set to 2D. The other thing we need to do is 1-to-1. So what that will do is it will, when we set 1-to-1, what we do is the solver calculates a single conductance from each primary element to the nearest secondary element. So we've got our beams. It'll create a conductance from each of the beams to the nearest. I want to do it the other way around then. So here, what I want to do is I want to, so let's first of all, I want to do this the other way around. So here, let me deselect all. I want to choose all of these to here. Okay, those are my 2D elements. And here, I want to choose the beam elements. So here and here. Okay, 1-to-1, and the overlap direction is the primary elements now, because those are the 2D, and I want to choose the 1D for the beam elements. Okay, so one more time, the primary elements are the rail surfaces, and then the secondary elements are the rail beams. We do a 1-to-1. So what that does is it selects, for each of the primary elements, it figures out the closest element in the secondary group and connects them with a thermal coupling. Okay, and it's a perfect contact, only with overlapping elements. Okay, so then we click OK. And then this looks messy. So let's come over here and just make it invisible. And so there we are. Okay. And so that completes basically the meshing. If I come over here and save everything, that's the meshing of the frame. Okay, thanks for listening.